Welcome to today's chemistry class. Still looking at stoichiometry and more concept. In this one, let us look at empirical formula and molecular formula. So we are going to look at empirical formula and molecular formula, and to start with, let us start by looking at empirical formula. And the first thing, let us define what empirical formula is. And this is just a formula that shows the simplest ratio of atoms in a compound. So the formula that shows the simplest ratios of compounds, of atoms in the compound. That is what we call the empirical formula. In other words, it's just the simplest formula. Okay. Now, before we even go into, because our main objective here at the end is to be able to work out the empirical formula. If you are given masses of the elements in the compound, or elements of the compound. Also, if you are given percentages by mass of elements of a compound. So that is what we are going to look at. Okay. But before we get into that, it is very important that we familiarize ourselves with the steps that are involved in order for us to write the chemical formulae, the empirical formulae successfully. Okay. So the first step here, we look at the steps. So steps in writing the empirical formula, or in working out the empirical formula. So one of the steps is that you need to identify the elements contained in the compound. That is first step. You'll be given compounds. You'll be given an element in a compound. Okay. And like I said, it's either you're given their masses or percentage by mass. So you need to identify them. What are the elements contained in that compound? Then the second part is identify the masses or percentages by mass of the element contained in the compound. Like I said, you might be given the masses of each element or the percentages. Okay. And the third step that you can look at is divide the masses of each element by relative atomic mass. So divide the masses or percentages by masses of each element by relative atomic mass. It's more like you're finding number of moles, or you're finding number of moles rather. Then divide the answer by the smallest value. Okay. Divide the answers by the smallest value. Then of course you've written successfully the empirical formula. Okay, so these steps, let us now actualize them, or let us apply them in this example. So a compound contains 40% calcium, 12% carbon, and 48% oxygen. Determine its empirical formula. So please, this one was not supposed to be carbon dioxide, instead carbon, just carbon. Let us keep it carbon. So a compound contains 40% calcium, 12% carbon, 48% oxygen. Determine its empirical formula. So what are we going to do in this case? So look at the first step. The first step, we said we identify the element of the compound, or in the compound. So in this case, we have calcium. So I can write here calcium Ca. Then we have carbon. I can put carbon here. Then we have oxygen. I can put O here. I can align them like this. Then what is the second step? If we are to go back, the second step, identify the masses identify the masses or percentages by mass of the element contained in the compound. So we are going to go here. Calcium, a compound contains 40%. So for calcium is 40%. Then for carbon is 12%. Then for oxygen is 48%. So I've done the second step. Then the third step, divide the masses of each element by relative atomic mass. So you divide the mass or percentages. So these percentages, you treat them more like masses. Okay. So you divide each of these by the relative atomic mass of the element involved. So in this case, the relative atomic mass of calcium is 40. From the periodic table, the mass of calcium is 40. Then that of carbon is 12. Then that of oxygen, it is 16. Okay? Let us look at the fourth step. So, which means here when we divide, we are going to find answers. Here we are going to have a 1. Here also we are going to have a 1. Then 48 divide 16 should be able to give us a 3. Okay? So that is what we have. Now, the fourth step, we are supposed to divide the answers by the smallest value. So of these values that we found 1, 1, 3. So which one is the smallest? The smallest, of course, is 1. So you are going to divide 1 throughout. Divide 1. And what we find as the answer, here it is going to be 1, here it is going to be 1, and here is going to be what? 3. So now finally, we can write the empirical formula. So the empirical formula of this compound that contains 40% of calcium, 12% of carbon, and 48% of that is oxygen. It is going to be written as, so calcium, there's just 1, then carbon, there's 1, then there's oxygen, which is 3. So now these ones do not even count. So it's going to be calcium carbonate, like that. So this is the empirical formula. Have you gotten that? So this is the empirical formula. This is the simplest formula of that compound. So that is how we successfully write it. I guess you followed the steps. So let us go through the steps once again. So the first one, identify the elements contained in the compound, like we've done. Then the second one, identify the masses or percentages by mass of the elements contained in the compound. The third step is divide the masses of each element by relative atomic mass of the elements. Divide the answers after you've done, you found the answers after dividing. Now you are going to divide the smallest more throughout. Then answers that you find, and finally you've written the empirical formula. I guess there's no problem up to this point. So please, if you have any challenges up to this point, make sure that you are able to pause the recording, or perhaps you might need to go through once again. All right, so that is what we can look at in terms of the empirical formula. Let us move now to look at the molecular formula. What about the molecular formula? So what is the molecular formula, by the way? So the molecular formula is the formula that shows the actual number of atoms of each element in a compound. For the empirical formula, we just said is the simplest formula of a compound. In other words, it's a skeleton of a compound. Okay? Then now the detailed one is what we call the molecular formula. You can look at it that way. So in this case, the molecular formula is just the formula that shows the actual number of atoms of each element in a compound. And I guess up to this point, you are able to tell the differences. So in other words, here what we are saying is that you come up with a molecular formula after finding the empirical formula. So the empirical formula is a skeleton. Then now you're going to build on that one to come up with a detailed one, which is called the molecular formula. I guess you get it right. Okay, so in order for us to determine the molecular formula, so this is the only thing that you need to know. In order for us to determine the molecular formula, molar mass, okay, so these are the things that should be known. Molar mass and the empirical formula should be known. So like I said, you start by finding the empirical formula first. That is when you go to the molecular formula. So please, if you find a question asking you to find the molecular formula, you are not just going to go straight. You start by finding the what? you start by finding the empirical formula. That is when you can find the molecular formula. For molar mass, it might be given, or you be given number of moles and mass. In other cases, for you to find the molecular formula, what do you need? You need the molar mass and the empirical formula. Now, in other cases, you might not be given the molar mass, but you be given the mass of that compound and also the number of moles, okay, by mass. So you have to find the molar mass using this formula. Okay, I guess that one you've gotten it. So how do you look at it now in terms of a formula? So molecular formula equal to empirical formula multiplied by n. Okay, if you want to find the molecular formula, you need to make sure that you multiply the empirical formula multiplied by n. Now in this case, since let's say you found the empirical formula previously, which means you have it, but how do you then find n, or what is n? So in this case, n is the factor calculated by the formula. So n is the factor calculated by the formula, this one. So you find n by dividing the molar mass that you are given, divide the empirical formula mass. So which means the molar mass that you're given, then you have to find the molecular mass of the empirical formula that you found. Then when you divide, you find your n. Okay? Let us look at this in terms of an example. It will make sense. So here is an example, and the question reads, what is the molecular formula of a compound containing 40%, that is 40.1% of carbon, 6.6% of hydrogen, and 53.3% of oxygen, if the compound has the relative molecular mass of 60? Okay, has the relative molecular mass of 60. Now, for us to find the molecular mass, what did I say? The first thing, we need to find the empirical formula. How do you find the empirical formula? The first step, we identify the elements that are involved. So what are the elements involved? I can see carbon here, 40% of carbon. Then I can see hydrogen, 6.6% of hydrogen. Then I can see oxygen, 53% of oxygen. So I can write them like that. Then now it's time for me, the second step, to identify the masses, or their masses, or percentages. So the first one, which is carbon, is 40.1, hydrogen is 6.6, and oxygen is 53.3. Okay, so what is the next step for me now? So the next step, we said you divide the percentages or masses by the relative atomic mass of the elements. So in this case, for carbon is 12. Then for carbon is 12. For hydrogen is 1. Then for oxygen is 16. So now what are we going to have at this particular point? What are we going to have when we divide? So now what we are going to have for the first one, that is 40.1 divide 12. So here I'm finding 3.34. Okay, so please be able to divide 3.34. Then here I'm finding 6.6. Then here I'm finding 3.33. Okay, now let us go to the next step. So the first step is this one, the second step is this one, the third step is this one, the fourth step, divide the smallest more throughout. So the smallest of the three is 3.3. There's a 4 here, but this one 3. So it is 3.33, divide 3.33, divide 3.33. Okay, so what are we going to have? So for the first one, we are going to have a 1. This one we are going to have 1.98. This one we are going to have a 1. Now 1.98 can be rounded off to 2. So this one is just as good as 2. So now we can write the empirical formula of this, which is carbon. How many are they? 1. In the middle there's hydrogen. How many are they? 2. So it will be like this. Then oxygen, how many? 1. So this is the empirical formula that you found. Have we written the molecular formula? No, we are yet to go there. So now we are saying for us to write the molecular formula, so molecular formula, let me say MF is equals to empirical formula times N. So the empirical formula, we have it, which is this one, but do we have N? No, we do not have it. So N, how do we find it? Molar mass divide, what do we divide with? Empirical formula mass. I'm just abbreviating this, but you can write in full. So here N is equals to the molar mass. Look at this. The question, in the question, this one we are given, if the compound has the relative molar or molecular mass of 60, so this one on top we are given, it is 60. Divide the empirical formula mass we find for this one. So we have oxygen, which is 16. We have hydrogen, which is 2. So we find the empirical formula mass, please. So this is 16. This is the 1 multiplied by 2, which is just a 2. Then carbon is 12. So we are going to add 16 plus 2, which is 18, plus 12, I guess is giving us a 30. So which means the down part here is 30. Then if you divide this one, it's going to give us a 2. Let us write the molecular formula. Molecular formula is equals to 2 multiplied by empirical formula, which is CH2O. So in this case, we are going to have 2 multiplied by carbon is going to be 2. Carbon is going to be 2. Then hydrogen is going to be 4. Then of course oxygen is going to be 2. So that is the molecular formula. I guess you followed. So that is how you write the molecular formula right here. I guess there's no problem up to this point. Okay, let us look at one more example that is going to encompass the two as well. So we can look at this exercise. So I wanted you to do this one, but we are going to do it together. But please, if you find a challenging question here, be able to bring it out so that we can answer it all together, or I can make a video just on that particular question. An organic compound contains 40.00% of carbon, 6.67% hydrogen, and the rest is the oxygen by mass. The mass of 0.02 mole of the compound is 3.6 gram. Work out the empirical formula. Okay, so look at this one. What is the first step? We identify the elements involved. So in this case, we have 40.00% of carbon. So we have carbon. Then 6.67 hydrogen. So we have hydrogen. Then the rest is oxygen. So we have also oxygen. Now look at this. The second part, we identify their percentages or masses. So percentages here, carbon is 40, which is 40.00, just the same as 40. Then this one is 6.67. Then this one is the rest. Look at this one. So when they say the rest, it means that percentage, you know, this out of 100. So if you have 40 and 6.6, then they say the rest is oxygen, which means if you add 40 plus 6.67 minus 100, what is going to remain is for what? Is for oxygen. So if you subtract 46.67 minus 100, it's going to give you 53.33. Okay, that is what we are going to find. So that is the percentage of oxygen. Now look at how clever the question was asked. Someone, if you are used to everything is given already, you'd find it challenging answering this one because of the term the rest of, or because oxygen is not given. So you need to know that percentage is out of 100 if you are given in percentages. So you just have to add what is given, then subtract 100, that is what remains, or subtract from 100. Okay, so we are done with the second step. So the other step now, we need to divide each of these percentages by the relative atomic mass of each of these elements. So for carbon is 12, this one hydrogen is just 1, then this one is 16. Okay, so let us find the moles. Now the first one, that is 40, divide 12, we are going to find 3.33. Okay, then for, or let me just put here 3.33. Then for this one, we are going to find 6.67. Then for this one, it is also 3.33. Then here, the smallest one is 3.33. So we are going to divide 3.33, 3.33, then 3.33. What are we going to have? Here we are going to have 1. Here we are going to have what? Automatically, this is a 2. Then here we are going to have a what? A 1. Okay, so that is what we have. Now we are writing the empirical formula, so we can write the empirical formula successively. So empirical formula equal to how many carbons? Carbon is just 1, hydrogen 2, then oxygen is just 1. So it is going to be like this. This question is more like the first one that we've answered, or the question that we've answered at some point. But of course, you are going to see, or you are going to see the difference in terms of when it comes to calculating the molecular formula, and of course a slight difference on the part for oxygen, of which is not given. In the previous one, it was given. All right, let us look at now the molecular formula. So for the molecular formula, you know that we need the empirical formula. Okay, so the empirical formula, we already have it. So to find the molecular formula, it will be very easy. We said molecular formula is equals to empirical formula multiplied by n, of which n is equals to mass. N is equals to, yes, n is equals to molecular mass of the, or molar mass of a compound, divide the empirical formula mass. Okay, empirical formula mass. Now let us look at the molecular mass. Here, are we given the molar mass? I mean, are we given, look at this, the mass of 0.2 mole is 3.6. So in this one, we are not given the MR. Instead, we need to calculate it. From the formula, number of moles is equals to mass over MR. We can divide the formula for MR, which we are going to say MR is equals to mass divide number of moles. So in this case, we are going to divide mass, which is 3.6, divide 0.02. And in this case, it's going to give us, what is the answer that is going to give us? Should be able to give us 6. Okay, so be able to divide, and let us see if it will give us 6. Let me just confirm with my calculator. So that is 3.6 divide 0.02. Oh yeah, no, not 6 please, but 180. So this one, it is going to give us 180. Okay, so 180 is the one that we are going to use now. So we go to this one. So we are going to say 180 divide. Then the formula mass for this one, what did it give us? This one we said is 16. Then hydrogen there too. Carbon 1. So 12. So this one gave us what? This is 10. Remember one, this is 30. So it gave us 30. So divide 30. And this is going to give us 18 divide 3, that is 6. So our n is equals to 6. And therefore, molecular formula is equals to 6 multiplied by the empirical formula, which is CH2O. So if we were to multiply here, it will give us C, C6, H12, O6, and this is glucose. So that is the molecular formula. I guess you've enjoyed the lesson, and of course you understand better now if you had challenges. So please, if you are interested in joining us for lessons, physical or online lessons, you are free to get in touch on the number 0976 40 2563. So we deal with these exam boards. So we have ECZ, IGCSE, GCSE. So if you are writing exams in, or you are having the exams in any of these exam board, you are free to contact for online lessons and also for physical lessons. For physical lessons, we are found in Lusaka, that is in Kabwata area near Kabwata Primary School along 8th Street. So if you are interested, you can just get in touch. Otherwise, we can end here and see you in the next one.